Good morning if you're out on the West Coast, and good afternoon if you're farther east than that. I'm Elizabeth Christensen. I'll help host our webinar today. I see a lot of friendly faces in the audience. We've got some couple engineers, some of our partners, some of our clients that I know. So I know there's a good amount of folks here that are excited to hear more about Crunchy Data Warehouse and what we're doing with on-premise architecture. Today I've got Craig Kirsteins, our Chief Product Officer, and then Brian Pace, one of our distinguished solutions architects. They're going to kind of take us through the Crunchy Data Warehouse product, sort of what it is, why we're building it, kind of how it fits into your kind of data needs and analytics and sort of bigger picture stuff. Brian's going to offer a pretty in-depth demo. We'll have plenty of time for questions at the end. There's a Q&A section at the bottom if you'd like to use that. I'll try to keep an eye on the chat as well. And then I have a few polls I'll be asking throughout the conversation just to kind of get a sense of what people are doing and how people are using data analytics today. If I can help with anything during the webinar or afterwards, feel free to reach out. We'll have a recording of this available, so if you need, if you missed part of it or need a recording after, feel free to let us know and we'll make sure and get you that. But yeah, I'm going to kick this off to Craig. Thanks so much for being here, Craig.
Cool. Thanks, Elizabeth. We'll go ahead and jump right in. So first, kind of want to give an overview of what Crunchy Data Warehouse is, a little bit of background. As Elizabeth mentioned, we'll hand it over to Brian in a little bit for actually some code and demo and in-depth walkthrough, and then kind of back up to, how can you think about using this? In large part, there's a lot in here, and kind of want to show you the bucket of tools that exist within the toolbox for you to kind of explore and think and apply to your use cases, but then also show you some clear defined use cases that we've seen it create value. So Crunchy Data Warehouse, completely new offering from Crunchy. It's been in development for over 18 months, and that's not just a single kind of developer hour. That's a dedicated team that's been working on this for 18 months. A team that has a rich experience in distributed systems and in building Postgres extensions. So from data warehousing to distributed systems to Postgres extensions, kind of a world expert team that we've grown here to build this over the last 18 months. We initially launched it in November 2024, available on our managed service on Crunchy Bridge. And then, as Elizabeth mentioned, this is now available on premises as of the end of last month in March. So if you have questions on how to get that up and running on premises, reach out to your rep or point person at Crunchy Data, and we can get you connected there. In short, we extend Postgres via a collection of extensions to be a more modern data warehouse. And I'm going to come back around in a little bit on what do I mean by modern data warehouse. Data warehouses aren't new, but this is very much a new modern take on them. So you can do many things that traditional ones could as well, but also work more seamlessly with your data. And so part of that is you're now able to import and export easily from a data lake. So data sitting natively within S3, you don't necessarily have to ETL and move that around. You can work with it natively as it sits. We work with a number of file formats, things like Parquet, Iceberg, CSV, JSON. If you're not familiar with Iceberg, it's a new emerging format, a common standard. Iceberg Summit just wrapped up in San Francisco yesterday, was a massive event, a Apache standard that has a collaboration of a lot of companies. It's actually fascinating. It came out of Netflix and Apple, but collaboration from Databricks, from AWS, from Snowflake, all collaborating on this open data standard. And so you've got a full managed Iceberg experience, which is really efficient for columnar data. So you get good compression of data, efficient querying it. We've got an adaptive query engine in it. So you can mix and match your transactional analytical workloads, local NVMe caching. And so the NVMe caching is great for performance, though I will say even with uncached data, you see great performance. Oftentimes when you're going to disk in Postgres, going to disk versus being in memory is like 100x performance difference. Here we're talking a 1.5 to 2x performance difference of whether it's in the local NVMe cache or going directly to S3. So regardless, you've got really fast analytical queries. Now, Brian, you want to flip ahead one? Now, if I back up a little bit, if you're not deep in the data world, right? There's really two camps and two workloads that this is not new. Like this has been the case for the last 30 years of databases. You've got OLTP, online transactional processing systems, and OLAP, online analytical processing systems. On your OLTP side, you can think of this as your operational system of record, right? This is your standard SaaS apps, high rate of inserts, updates, deletes, small queries. Your standard, CRM application is largely a big CRUD app doing small inserts, update, deletes. You want low response time, like single millisecond on your queries and your inserts. These are typically user facing, right? Tens, hundreds of thousands, millions of users are your OLTP systems, right? Even if it's still small, low user count, but user facing directly kind of hitting these applications, low latency. And so on the one side, right, you've got, hey, give me all of my orders, and very targeted. While I've bought a lot of stuff over the years from Etsy, I'm still not at hundreds of thousands of orders of from Etsy, right? It's still small tens, hundreds of orders, small targeted lookups, right? On the analytical side here, this is often business facing dashboards, it's internal or roll ups. While you may expose some OLAPs kind of use cases directly to users, these are more predefined reports on dashboards, right? And still, even on those dashboards, you don't need the same kind of single millisecond response time. Here, if you pull up a reporting dashboard in Salesforce, you're okay with 50 milliseconds, 100 milliseconds, sometimes even 1 to 2 seconds. Generally, you don't want these to be multiple minutes, though in cases, very complex kind of data warehousing queries can take more of that form. And now there's often been a trade-off, right? On the one side, on OLTP, you've got row-based storage. On the other side, you've often got columnar storage. And so columnar is not as friendly for single row inserts or updates or single row lookups. So you've got these kind of two storage formats and two workload patterns really at odds. And this is, again, not new. This has been the case for 10, 15, 20, 25 years in the database world. Now, Postgres itself, historically not super friendly for OLAP. There's a lot of reason for this, right? Postgres, its planner is optimized for really quick planning and really efficient retrieval, whereas data warehouses have a higher planning time to compute multiple query plans and find the most efficient one. Postgres is doing a lot of fine-grained locking on its transactional system. Works great for quick inserts, updates, deletes. For large analytical workloads, not so great. Parallel
So
query has
Craig,
come to Postgres. Yeah, Brian, go ahead.
yeah, Craig. So yeah, I mean, the community's tried to we tried to attack this in many different ways over the years, right? I mean, and I've looked at the poll. What was it? 35%. I bet they're still doing OLAP or analytical stuff with just Postgres.
Yeah, and you can absolutely do it. And I think I often see when you're doing that stuff on Postgres, it's kind of considered the accidental data warehouse, right? I had a big Postgres database and I started throwing analytics and I started adding other systems to it. And you can push Postgres reasonably that way and tune some knobs and you can get a little further. I think when we get to the demo, right, you'll see the scale of difference in performance of what you can get from a true analytical database. Now, what's fascinating is Postgres isn't new to this world. Like, thank you. Like, there was Citus, which people often, miscategorize as a data warehouse. But if I go way back, Amazon Redshift was par excel, which was Postgres 8.2. Postgres has a long history of essentially taking it, forking it because of its licensing, because of its great code base, because of how you use it is in academia. Fork it, then you add, extend kind of and change the storage type to make it columnar, right? And then you make it MPP, massively parallel processing, to improve the parallel query of it. Um, and what's fascinating is when you fork Postgres over time, it's frozen in that time. And so, you know, I believe Redshift is based on what was par excel, which was Postgres 8.2. I didn't check ahead of time. I believe that is over 14 years old now, and it may be even older. I don't know if you or Elizabeth want to fact check me how old Postgres 8.2 is, but that's the version of Postgres you're working on. And while you will try to kind of catch up bit by bit by bit, when you're a fork of Postgres, you're very much kind of frozen in time from that. And so, if I go back and date myself a little bit, over 15 years ago, I was working on a Postgres company that forked Postgres. And we basically turned Postgres into a streaming MapReduce kind of engine. When a new version of Postgres came out, it would take us between 3 and 6 months to rebase to that new version. And it just got harder and harder and harder. In comparison, by building and extending on Postgres as extensions, right, with those low level extension hooks, we're able to stay current. So you don't miss out on things like, index improvements. There was a great improvement in Postgres 17 around pushdown of in clauses so that you can still use B tree indexes. On our own workload on Crunchy Bridge, we saw a 20% boost in performance on those queries. That's completely free. You don't get that when you fork away, and now you've got to go and maintain that, right? So the fact that we're extending Postgres, huge. But you look around, there's there's Redshift, there's Netezza, there's Greenplum, there's Astrodata. All of these are kind of older data warehouses that were forked away from Postgres, and you're frozen in time. And so the fact that we're an extension is truly kind of a unique thing here, and one piece that is going to allow us to stay current. Now,
I was getting ready to say, Craig, fork is a curse word at Crunchy. So you owe a lot of money to the curse jar. And for those who don't know what a curse jar is, if you say an ugly word, I had this growing up. I don't know if you all did. You had to put money in the curse jar. Well, Craig, you said fork a lot of times.
thank
Owe a
you for
lot of
calling
dollars
me
to
out there, Brian. Thank you very much. We'll have to add some censorship on YouTube. And so I've talked a little bit on what is a modern data warehouse, right? And so, yes, you want columnar storage, you want fast analytical queries, right? But I think there's more to it than that. And so, one is reducing the need for ETL. When you've got an ETL pipeline, you've got a production Postgres database over here, you've got an ETL pipeline, then you've got your data warehouse, you've got a lot of latency, you've got another system to maintain. How much can you work on data as it sits, right? And predominantly S3 is being used not just as a storage layer for images and backups, but as a drop zone, as a landing zone for data, right? As an API between teams to say, like, I don't want to ETL this. I don't want to move it into my database. I just want to query it as it sits in S3, right? And so rich data lake capabilities that you can work on data where it sits is one big piece that differentiates it from other data warehouses. The other,
That message, Craig, really kind of resonates too. I mean, there's so many conversations I had with customers. They're like, I need to figure out how to get my data in or out of Postgres to some data lake easier. And then once they see data warehouse, it's like, wait a minute, maybe I don't have to move it. I can just use it right where it sits.
right, like we just canceled the whole project. Like we don't have to do that. It's great. Open data formats, another huge piece. I had this epiphany. It was about a month ago. Postgres got pluggable storage engines about 4 years ago. And this was great. The Postgres community was so excited. Like, all right, we're going to have an engine that doesn't have MVCC and vacuum's not as intensive. And we're going to have this engine and we're going to have this engine. And we started building these engines. The problem with building a new storage engine is it's expensive from a time perspective, from an investment, from an engineering perspective. And what we've seen emerge is Iceberg as this open data format. And what if the storage engine wasn't a new engine in Postgres? What if it was a completely open standard? And Iceberg, you can go and point Spark at it. You can go and point dbt at it. You can go and point all of these other tools. And we see other data warehouses starting to adopt it. We've been working with Iceberg now for 18 months. Following along very quickly to its development. Iceberg has multiple kind of phases and stages. There was V1, then V2. They're working on V3 now. They're already talking about V4 and the improvements. It's a fascinating open data format that we'll get to it in a little bit. And, if you're new to Iceberg and I never heard of it, and no, it's not that S3 thing for storing stuff long-term in Amazon, for your backups of your photos. It's often kind of conflated. We had too many ice and glacier things in the data world. But it's a fascinating open data type. Now we talked about OLTP and OLAP, and we've had this world of, how do we, HTAP, hybrid transactional analytical processing. How do we mix and match both of these worlds, right? Instead of ETLing in completely different workloads, how do these play together? I think we're going to see some of this live in the demo. The fact that we can do analytics queries and transactions together, we can seamlessly move data back and forth, gives us one engine to do this. And we don't need 2 and 3 and 4 different systems. We've got one, which just simplifies everything for us. And then your data processing pipeline, right? How do we get data in and out? How do we roll up data? How do we take advantage of things like medallion architectures? To me, when I say modern data warehouse, yes, there's columnar storage in here. Yes, there's fast querying, but there's a lot more than that of how do we work with data that is greatly simplified. So I'm going to quit rambling on some slides and let Brian, you take a turn at rambling and be way
Hey,
more, interesting than me
hey, Craig,
on some actual code.
I was
Yeah,
just going to
Elizabeth.
jump in before you do the demo. There's a couple questions in Q&A that I think will be pretty fast if you want to do that
Sure.
real quick.
Fire away.
So the first question is, can the whole thing run on-prem?
Yes. So we released it. Brian will actually, I think, get into a little bit of this, maybe not super deep in the demo. If you're familiar with Crunchy Postgres for Kubernetes, it is a new separate product that built on top of that, but it is available to be run fully on-prem, whether that's self-managed in AWS in a disconnected environment, as long as you have some S3 equivalent storage. So commonly we see that's MinIO. If there's something else and you have a question, let us know on that. But today it is on-prem, running and managed in Kubernetes, yes. If you need something outside of that, let us know. And then if you need it, you don't want to manage it on-prem, we've got the fully managed service for it. So
And then there's two questions that are kind of related, so we'll just do it as one question, and that's just, do you support GeoParquet and geospatial queries with Crunchy Data Warehouse?
we do. We support GeoParquet. You can natively read and load shape files and other things. There's a lot of, beyond just the data warehousing piece, a lot of ease of use in working with geospatial files that is shockingly simple. I don't know that we're going to get into that today, but we can definitely, if you have want a more curated demo of that or follow up, short answer is yes, we do support GeoParquet and quite a bit on the geospatial side.
And there's quite a bit of GDAL support too. I think I worked on a bunch of the docs for that. So most file formats that work with anything GDAL will work with data warehouse. And then there's one last question here. Does Crunchy Data Warehouse require Kubernetes?
Yeah, today, if you're running on-premises self-managed, it is via Kubernetes today.
But we also have a cloud managed option too, right, Craig? So if you're not running on Kubernetes, but you're able to run in cloud, in public cloud, then you can use the Crunchy Data Warehouse via Crunchy Bridge.
Correct. And all of that runs in completely isolated VPCs, can support VPC peering, private link. So it's not a multi-tenant cloud. It's actually a single tenant cloud instance for you, completely isolated from all others. So if you're able to run there, then you don't have to touch Kubernetes at all.
And then, if you want to go ahead and kick off your demo, Brian, I'm loving all the questions. So if people want to keep kind of piling stuff in here, we'll kind of get to the rest of that after the demo.
Yeah. Most of the time when you give a demo, you try to answer questions. And I think our goal of this demo is promote questions.
Yeah, that's true.
That seems to be what it does the most. So awesome. Going back to the, hey, what if we don't run Kubernetes? It's one comment I'll throw that way is we're seeing this, I would almost say we're mirroring the cloud on-prem where customers are creating a Kubernetes cluster that's dedicated to databases, and it almost becomes a on-prem database as a service or database farm. So if you don't even have it today, something to think about. So if you're familiar with our Kubernetes offering with our operator, a little background on what I've done before joining the call is I just used this simple manifest to describe to the operator, hey, I want a data warehouse cluster. Deployed that cluster, and it did all the magic behind the scenes of standing up an HA Postgres cluster. So I have failover and I have backups and all that stuff's automated for me. And all I need to do is just describe to the operator what that is. So moving into the data warehouse side of the equation, I'm just going to start simple. I've got an object store here running on-prem. So there's the we're drinking our own Kool-Aid talking about the that have to be in the cloud. Can it be fully on-prem? So this object store is on-prem. I've got some CSV files. So it's one thing to view it in the browser, but one cool thing that we can do right off the bat, and I've already connected to my cluster, is I can query that bucket using straight SQL. So you can see here that I've run that query. Let me just make this font a little bigger so we don't get some wrapping going on. Yeah, there we go. So you can kind of see everything we see. Yeah, this is cool. So I can see what files are in the bucket, whether they're CSV, JSON, Parquet, GeoParquet. Gosh, the list is 2 slides long now, what file formats we support, right, Craig? And most of these, not only can we read to them, we can write those formats, as you'll see a little bit later on. We do have an extension available. Some of the things that I like is we've got a timestamp here. We've got a tag that is the checksum, the file size, all these things that now you can now use SQL to key off changes or new files. And this bleeds right into PG incremental, that where we could create this data pipeline right in the database. I wish there was time today to talk about PG incremental. I think it's very cool what the teams developed there. But what I want to do, where most of the conversation takes place with some of our customers, is, hey, I need to get this data in. It's sitting out in an S3, and it's in some bucket. So I'm just going to create a standard Postgres table, and notice that I did not give it any of the what we would assume to be or always taught to be is the required parameters. Right? I did not give it any column names or definitions. Instead, I just said, hey, I want you to go look at this CSV that's out there, and I want you to, kind of derive the format of the table from what you see in that file. And that's indeed what we ended up with. And now I can copy that data in from the S3 directly into my Postgres table with one command. So no more loading the library to connect to S3, reading that file from S3, getting a connection to the database, loading it back into the Postgres table. So very easy to copy data in. I could reverse this, copy the data out. One cool thing that I can do when I'm copying out is I can copy from a subselect. And in that subselect, I can just select specific columns, use filters to select specific rows. If you have to do data masking and mapping, you can do that as well. And I also could have done this in one step. So instead of saying definition from, I could have said load from, did that all in one step. But just to be fair with the query that I'm going to run, I'm going to throw an index on that table, as we often is common for Postgres heap tables, because that's, as Craig was saying, that's what they're designed to do. But CSV, gosh, what was the format? Have we asked the format question, Elizabeth? I don't know if we were going to do that or not.
Yeah.
CSVs aren't that exciting, right? I know they're not Craig's favorite to talk about CSV files. He's like, "Come on, Brian, get past the CSV."
They're fine. They're fine. But like, let's go a little bigger on our data.
CSVs have been around for a long time, right? All right. So what have I done? We looked at the data. We imported the data. Now let's copy the data out and let's get to some exciting stuff. So I've got my standard stock table. It's got stock summary from every day, I think back to 1962. I'm not sure how well 1962 data would help you in your trading today, but We've got history all the way back. So I'm just going to copy that out to a Parquet file. And of course, it's Crunchy Data Warehouse under the cover that's helping create this Parquet file, put it out on the S3 bucket, and it's just that simple to move data out. And I could have sent this to CSV. I could have sent it to JSON. I could have sent it to Parquet like I did, or any of the other formats that we support. So easy to get data in, easy to get data out, and it will take just about 30 seconds or so for this copy command. But Craig, while we're waiting, word about Parquet.
Yeah, I mean, if you're not familiar with it, right? Like I describe it as a columnar CSV, right? It's self-describing, it says this is this column type, this is this, but if you think about it, I think you're gonna get to this. It's like a CSV, but it's like here's this point in time, right? So as soon as it's changed, what do you do? But I mean, every kind of language has libraries for easily reading Parquet, working with it. So if you literally have some pile of Parquet files sitting around from, logs that are dumped from, Vector, CloudWatch into Parquet, you could just read those easily. But because they're already columnar, it will go and compress all of that for you.
Yeah. Yeah. So nice. And you can see how compact it is. This is the same data. So it's 2.8 gig in CSV, almost 25 million rows in Parquet is 800 meg, give or take a few megs there. So I've copied that out. Now we talked about, hey, do I have to move data? We've seen it, being very easy to move data. Now you can say, that Parquet file that I just created, I'm gonna create a foreign table on it. So now I've got this table that looks and feels and behaves just like a Postgres table, but it's really looking at a Parquet file in my object store. And then here's when it comes back to why did we build this, and why is Postgres slow for OLAP, and all those questions that we've built up on. Here's the proof that's kind of in the pudding, right? Here is a typical analytical type query, doing some of that data analysis, summarizing that analysis. And when I run this query against the Postgres heap table, it took about 3.5 seconds. And now if I run that same query, but instead of looking at the Postgres heap table, I'm going to look at the Parquet foreign table that we created. So I'm going to query this Parquet file in the object store using standard SQL as if it was a Postgres table, and there is 139 milliseconds. And probably 80 of those milliseconds is my high-speed network to my object store. So there's why we built this. Now, Craig, you were talking about, okay, what if I now needed to update some of that data? And that's where Iceberg comes into play. So I don't know if you want to say a word about Iceberg at this stage, or go into what Iceberg
Yeah,
is.
perfect. So Iceberg, as I mentioned, it's an open file standard, right? It's a Apache, part of the Apache Foundation. It came out of Netflix and Apple, which is fascinating to me because you don't think of Apple as known for doing open source. Netflix does quite a bit. Um, CSV, much like Parquet, both of them, hey, I can email Brian a CSV file, but as soon as my database changes, like that's it's out of date, right? And so Parquet long term has been viewed as kind of immutable. It's this point in time exactly. Now, if you think about it, though, with Iceberg, what it builds on is basically has this manifest and then catalog of, all right, now I'm going to have Parquet edition files and new insertions and updates and deletes, right? And I'm going to layer on this metadata and catalog to say, hey, I've got hundreds of Parquet files that comprise my data over here, and I've got these deletion files, and then I've got, new insertion and update files to really turn this set of files on disk into a living, breathing database, right? In many senses, this is how Postgres works. When you delete a row from Postgres, it doesn't go in and delete the data, it marks it as dirtied, right? And so when you're doing, a search, it looks at the index says, Now let me go to disk and see if this is still there or it's gone. And so there's checks on deleted data, right? And when it's marked as dirty, it comes in and you can reuse that when you insert new data, right? So Iceberg, fascinating format. Now, that's what it is, how it works. The beauty of a lot of this is, and I think Brian's going to show, you can kind of just forget what I said. And it's once you have the mental model of like, Iceberg is for my analytics and I have this workload on Iceberg and that's how I use it. You don't have to worry about the internals of Iceberg at all, really. So, Brian, that helpful, Brian?
It is. It is. I think the key is it's a table format. And I think the struggle over the years, right? We've tried all different kinds of formats, but all those different formats needed some specialized engine, right? I think of Hadoop, right? Early on in the client server data warehouse attempt, right? We built Hadoop, and then we decided, hey, you know what? SQL's very, very, very helpful. It's a lot easier to write SQL than Java-based map and reduce, right? So
Yep.
here we are. We keep getting smarter and better in the data world for sure. So let's go ahead and create that. Again, you're like, hey, Brian, looks like you're just doing Postgres. Exactly. I'm creating an Iceberg table, and all I had to do was trigger the extension by using Iceberg. Again, notice I did not give it. I didn't have to give it, right? It's Parquet is self defining, as Craig pointed out. But I told it, hey, I want you to create this table. I want it to be an Iceberg table. And I want you to load it from this Parquet file that we just created. So I pulled data to the object store as a Parquet file, pushed it back as an Iceberg table. So now I've got this open table format that, one, you can use the power of SQL to query, just like just like it was a normal Postgres table. Get that same type performance we're getting on the Parquet file, and get the best of both worlds. Now, I want to go back and want to dig into the DML that Craig, you were talking about, and I think this pattern probably matches a lot of use cases, right? What do you call it? Accidental data warehouse.
Yep.
We
Yep.
we start with this table and it's got 100,000 rows in it, and that's cool. It's performing like a champ. But now it's got 1,000,000 rows. Okay, still doing pretty good. 100 million. Now we hit 1,000,000,000 rows, and it's like, okay, that's not great anymore. And that's kind of what we're going to simulate, right? We got this stock table. It's got data back to 1962. Nobody's querying data from 1962 for the live trading platform, right? To make decisions. So we're going to create this archive table. And notice I'm going to query. So I created a new Iceberg table. I just pointed it to a location. And now we're gonna just do a union. And the cool thing to note here is, yeah, I did a union here, but I'm joining a Postgres table and an Iceberg table. And to me, it's just straight Postgres SQL. Nothing specialized. It's the SQL that data scientists love, and they'll hug you, and you'll be their new favorite person, and you'll get free donuts when you give them the power of SQL back. But I've created that table, and now I'm just going to archive. And how I'm going to archive data from my Postgres table, so from my standard Postgres heap table, and I'm going to insert it into the Iceberg table all in one statement. And if that's not cool enough, this is not only in one statement, it's a single transaction. So if my S3 bucket hiccups right now, or we lose network connectivity, or something goes wrong, whatever we can't even imagine happens, this is all or nothing, right, Craig? I mean, this is like you don't
Yeah,
have
like
to.
I mean, the first time I saw this, it absolutely blew my mind. And I think we've got a question there, which we kind of answered live, where you can see we're seamlessly moving data in a transactional format from a row-based format over to analytical format with a returning CTE there. Like that little, 6 lines of SQL and really could be compressed down almost to what, 4 or so, 5? Like
Yeah.
that little tiny amount, in a transaction moves data from inside Postgres heap tables to Iceberg S3, updates the metadata, transactionally consistent, like mind blown. And now,
Yeah.
what we can do is say with things like PG incremental, PG cron, all right, let's start to run this every 5 minutes. Let's run this every 1 hour, like fully automated within our database without having to kind of layer on WD-40 and glue and duct tape to all these systems.
And the part I like, Craig, is think about when I was writing Java code and you were writing whatever code. You came up in the Rails world, right, in the Ruby arena. But you would go do your delete or grab your data, and then you would insert it, and you would do a count, and you would then go delete and do another count. Did I delete the right number of rows that I inserted, and what if I didn't? And
Yeah, this
yeah,
this notion of now transactional consistency across your transaction database and your analytical database without having to think about the ETL is a lot of simplicity.
yeah, absolutely. And cool, as you pointed out, I could have copied this data to a Parquet file, but that file is somewhat immutable, right? If I just needed to append to it, I can't. And that's where Iceberg comes into play. So I'm going to change my retention. You see, I moved all of that data except for the last 10 years, right? I did have data back to 1962, 25 million rows. I moved about 14 million rows off. I'm only going to keep 5 years. So I want to archive some more data. So all I do is just change the variable that I'm using in my delete statement up here, and just run that same command, and just append more data to my Iceberg table. Now, here in essence, I'm creating bloat. And those of you familiar with Iceberg may have lived the pain of compacting that table. I don't think that's an easy task. I think most people try to do it through Apache Spark or something of that nature. Um, but I've just created, multiple versions of a Parquet file out there. What do I do to manage that? Well, we've made it pretty difficult, I will say. You just got to remember to type vacuum, and there we go.
So
And
the beautiful part is actually now you don't even have to run that. Now we actually have auto vacuum support in. So like while you can manually do this, we're automatically monitoring all that in the background. Like vacuum is still our on hard mode. On easy mode, auto vacuum is running for you automatically, right? So instead now of millions of Parquet files from all these insertions and updates, we go and recompact millions of Parquet files down to a few hundred, so data is evenly partitioned and compressed into good searchable sized chunks.
yeah, definitely. So, man, what have we done? We've looked at data in the S3, we've imported it, we've exported it, we've put it in Iceberg. We've seen the short query, long query performance. Yeah. So is it time to kind of look behind the curtain? Can we give them a look behind the curtain, Craig?
Yeah, and we kind of had a little small version of this, kind of on an earlier slide, right? There's a lot going on here. There's a number of Postgres extensions. I believe it's 14 or 15 that if you think about them of like each one as an instrument within an orchestra, right? And on their own, they are fine. When you put them together, right? Just had my oldest band concert a week ago, and I'd heard all the practicing of the saxophone coming from the room, and it was fine. It was fine. But man, hearing the band come together, right? All the kids together in coordination, each instrument doing its part, it's beautiful. And it kind of fades away into the background, right? We've got this easy ability to write to and from Iceberg, the ability of a, DuckDB inside this, multi-threaded process, so for better memory management and support, the ability to easily connect directly to S3, right? You don't have to load the data, but you can. Iceberg, there's a catalog there that other things can point to, right? So if you're using something like a Spark or Python, you connect directly to it, it'll see the full Iceberg catalog. Function pushdowns back and forth between our vectorized engine and data types and all of the geotypes. Hey, Parquet and Iceberg have a map data type, right? Like a map structure. Postgres doesn't, so we went and created one for it. But all of this you don't have to think about, right? As you saw, like Brian never got into the details, never cast data types or this or that. You just, in some cases, he was actually doing less SQL by not defining columns because Parquet already knew it, right? You can still define columns if you want to, but like it's already done for you. Now, there's a lot of we've shown you some of the tools, right? Now, how do you think about using this? As we skip ahead to just a couple use cases we've seen, right? And so one is this kind of real-time analytics dashboard, kind of real-time analytics where you're ingesting a lot of raw data, right? This is common in IoT, kind of sensor data, event data. You're ingesting hundreds of thousands of millions of events per second, right? And Postgres can do this quite well with kind of multi-row insert or micro batching with copy. You can get, this is coming out of Kafka into a Postgres raw table, right? And from there, what you're doing is kind of constructing this medallion architecture, right? I've got a ton of raw, unfiltered data. I want to go and enrich this in some way. And you could do this with PG incremental, where you're incrementally kind of rolling up or aggregating data or filtering it or enriching it into, these, silver tables where it's kind of pre-aggregated and computed, rolled up to summary kind of gold tables, which your users then hit directly, right? So you've got data over here in Iceberg that can be rolled up into roll-up tables that can be rolled up into Postgres heap tables with indexes. So you can mix and match these, right? Now, if you still want to go and do raw analysis against the ingestion tables, you still can because you have that raw data directly there to be able to work with it. But you've got kind of this raw ingest into incremental views that are cleaned up data, tailored, kind of later processed, refined for the business directly. One common use case we're seeing. The
Well,
other one,
I'll jump in,
yeah,
Craig, real quick, if I can just hit on something that you said. Um, this is having these open table formats is great for migration. There's a few customers that I'm working with. They're like, hey, we got all this stuff written in Apache Spark. And it's like, great, just continue to use it. Just point it to, the Crunchy Data Warehouse as the catalog for Iceberg, and all of your Apache Spark works while you get back to where you want to be, and that's just completely in SQL.
yep, yeah, no, I
So,
mean, there's a lot of simplicity and power in here, right?
yeah.
The other one, this is actually almost an internal case study. So Crunchy Bridge, our database as a service, we store a lot of internal logs into CloudWatch. And so things like, audit logs, SSH, Postgres things, they're in a central CloudWatch instance. And we actually replaced this with our own Crunchy Data Warehouse and saved actually $30,000 a month on our CloudWatch bill. Our Crunchy Data Warehouse, like as a customer of ourselves, the bill would be less than $500 a month. And there, our logging engine is outputting directly into S3, right? And we're basically doing that wildcard search where, all right, new data for this day, for this hour. Let's move this via our incremental processing, the scheduler process with PG incremental, move that from basically a tarred up file, a gzip log file, I think it's TSV in this case, over to Iceberg. And so that process, right, we've got a foreign table that has our logs, that then we move stuff into Iceberg and that incremental processing happening every hour. And then, I mean, the engineer essentially was like, finally, I can just query all my logs with SQL, which is what we actually wanted all along. And so, I mean, it was kind of actually mind blowing to me. I, knew it would work. The amount of cost savings was pretty unbelievable for log management kind of and analysis right there out of the box.
all,
You know,
all my
the
many years at all my many years at City Craig, one of the tests that we always put to a vendor is, do you drink your own Kool-Aid?
yeah.
And we are definitely drinking our own Kool-Aid. You know,
And so, the final one and kind of where I'll end, right? Is this notion of a modern data warehouse, right? And if you think about legacy warehouses versus modern ones, again, right? That ability for removing ETL, you can query data where it sits, or you can easily move it from point A to point B, right? Iceberg as an open format means all of your data analysts that want to work with the SciPy and NumPy and Pandas and Python and Apache Spark and all those tools absolutely can. You as the data person don't have to worry about that or think about those other tools, but they're available to them, right? Because we're leveraging this broader community and collaborating and working with it with Iceberg means we don't have to invest as much in the storage engine ourselves, which means we can focus on other features and go faster. We saw that mixed transactional analytical workload and then the easy, I can't undersell this simplified data pipeline processing, right? To easily roll things up within the database seamlessly. There's a lot of beauty in the simplicity there that I don't need as much complexity anymore. And so, again, this has been 18 months in development from a dedicated team. Very excited about it. If you have questions, need kind of follow on, talk to your point of contact at Crunchy. We're happy to do follow-ons for demos, Q&A, all of that. If there's some more questions, we'll definitely hang around here a little longer. It's available on Crunchy Bridge as a managed service today and kind of self-managed through our Kubernetes distribution as well.
Hey, Craig, I think I've come up with a new term. We just call this data avengers.
I think there might be a trademark on that one. So we'll
Pull this superhero of data. I don't know.
I kind of lost Brian there
Cool.
for a second. Was that just me?
Yeah.
yeah, Brian, you cut out for a bit, but
I think you're back.
great question on the docs. A lot of the documentation does exist within the Crunchy Bridge doc. Yes, most of it does map to the CPK offering as well. And so the user experience is pretty much the same there. We have docs within our access portal for, how do you set up and configure this, right? How do you update your YAML and manifest for your Kubernetes cluster to work with this? There's a few extra options. Those docs do exist. We're kind of back and forth on, do we need an entirely new set of docs for the product, or do we mirror across? So a lot of it does exist within the Crunchy Bridge documentation. All of that does apply in the same format. There's a question of, are there plans to make it available non-commercially for like home lab dev testing evaluation before pulling the trigger? We have actively on the roadmap a local development container that will be very much slimmed down for local development, right? Meant to run on your local laptop, not with full backups and DR and HA and the full-blown monitoring stack. We are actively working on that. It's a lot of priorities competing for each other. I'm targeting for that this quarter. It may be late June. That's what we're targeting. It's not a firm timeline yet, but we are actively working on a development container to make that dev testing, that process, whether you're on Crunchy Bridge or self-managed, to make that easier to dev locally. So that is coming on our roadmap.
Craig, I think you have a fan in the chat. Somebody said that I think when you were showing kind of the Iceberg stuff and kind of how it works with Parquet files, that quote, "This is dope and solves all the small Parquet problems."
Yeah, it was. I was just having a conversation with one of our engineers from Iceberg Summit, and it was fascinating to me that he was there talking with a bunch of folks about how do they do compaction in Parquet and how do they worry about the small Parquet file. And he was actually talking about how Slack, who runs a large Iceberg setup, had forgotten to run their compaction for 2 weeks and had hundreds of millions of small Parquet files. And to compact those, you've got to basically bring that up into memory to do all of it, to handle deletions and other things. They booted up a 12 terabyte of memory instance to go and run all that compaction. And it was shocking the number of people running Iceberg not doing compaction, which is fine on day one, but on day 50, you're in for a world of hurt. And so the fact that this sort of fades away, there is very much a small Parquet file problem that can't exist. Because auto vacuum is running in the background and taking care of it, you just don't have to worry about it. For me, it was mind blowing. The engineer joked of like, hang on, we thought this was required for us to be a production ready data warehouse. Could we have just skipped all this hard work? I told him, no, don't get any ideas. But for us, we definitely hold that what is a production grade at a high bar, and it's already taken care of for you now. All right, I think we've slowed on questions. So thank you all. If you do have any follow-up questions, feel free to reach out. This is recorded. If you want kind of quick access to the recording, shoot us a note. We can make sure as soon as it's ready. If you want to, review it, rewatch, share with colleagues, happy to make that available to folks as soon as we've got it. We'll publish it more publicly at a later date. Thank you all for joining and hanging out with us. And again, if there's questions, please don't hesitate to reach out to your point person at Crunchy. Happy to follow up with follow-on questions.